Hey, it's another great day for some geometry. Are you ready to learn about Chapter 7? Similar polygons. New chapter, new adventures await. 7.3, proving similar triangles. Yes, we are skipping 7.1 and 7.2. And you can actually see some similar figures here, similar Buzz Lightyears. So, what are similar figures? Well, they have the same shape, but not necessarily the same size. We use this symbol, called the tilde symbol, to stand for similar. So anytime you see this, it's one single tilde, it means similar. Not get confused with the two tildes, which mean approximately. All right, so we know if they're similar if they have angles that are congruent, okay, and sides that are proportional, meaning the sides have to have equal ratios, the corresponding sides, meaning the sides in the same position form equal ratios. Okay, we're basically going to look at that in a lot of the examples later, the idea of proportional sides. Okay, the similarity ratio is the ratio between the sides. Okay, so for example 1, are these parallelograms similar? Well, you might think they are, except for the fact that the corresponding angles here are not equal. Okay, you have 120 degrees and 100 degrees. They are not similar for that reason. All right. Example 2, you have triangle ABC. It's similar to triangle XYZ. What is true? Okay, well, you can tell that angle B is in the same position as angle Y. So angle B is going to be 29 degrees because in similar figures equal corresponding angles, corresponding mean they're in the same position, have equal degrees. All right. Now, this is what I was talking about, corresponding sides being proportional. Okay, so you can make ratios of the sides that are in the same position, BC compared to YZ. Okay, that ratio, BC over YZ, is going to be the same thing as the other two pairs of corresponding side ratios, such as AC equal to XZ. All right, you could also say that's equal to AB over XY as well. All the ratios of corresponding sides are equal in a similar figure, which is pretty nifty. All right, let's go on to our first theorem. This theorem allows you to prove two triangles are similar. It's the angle-angle similarity. Well, all you need to know is two angles, okay? Two angles of one triangle are congruent to two angles of another, then we know it's similar. Remember, by default, if you know two angles are congruent, the third ones are also congruent. So, angle-angle similarity theorem. Okay? All right, so in example 3, let's go full screen for this. Okay, in example 3, we have this picture. MX is perpendicular to AB. Why are the triangles similar? Well, if they're perpendicular, that means we have a 90-degree angle here, okay? And we also have angle A congruent to angle B. Since they're perpendicular, we got the two right angles, so we have another two angles that are equal. And then we know the triangles are not congruent, but they're similar, okay? Because of the angle-angle postulate that you guys just learned about. All right, so all you need is two angles to match up in the two triangles. Then you know they are similar. They are not congruent. Angle does not prove congruence, okay? If it was angle side angle, you could prove the triangles are congruent. Okay, so here's another example. We have triangle ABC, whose measure is 61 degrees. Let me get my draw tool here. We can draw it on here. ABC is equal to 61. Okay, so we got 61 and 62. Okay, now we don't really know which one's 61 and 62, but we'll do the best we can with that. All right. And DEF has 57 and 62. Well, let's say that this one's 57, okay, because, well, we know these two are 61 and 62, so maybe C is 57. I don't know. So, and angle E is 62. Well, E and B match up already, so that's one angle. Okay, if we're going to prove these are similar, we need to see if the other angles are matching up. The remaining angle in triangle ABC, if you take 180 minus the 2 you know, is actually equal to 57. Isn't that nice? So we could say C is 57. Okay, of course, we just label these in any haphazard way. Okay, 61 could have been C and 62 could have been A. But regardless, you have two angles in the two triangles that are congruent. So therefore, those triangles are similar. Okay, we just proved that the two triangles are similar. You could probably want to go with the order that they give you. Like A matches up with D. Okay, and it's like you can't just like rearrange the letters of this one. We have the congruent angles matching up in the right order. A matches up with D, B with E, C with F, etc. So match up the like angles when you're naming these similarity relationships here. All right. Example 4 coming up. Going back to full screen land. Here we go. If triangle ABC is similar to triangle XYZ, find the value of X. Da-da-dum. Okay. So in this is where you have to realize the sides are proportional. Okay, the ratios of the sides are proportional. Okay, so like if we take X and we put it with its corresponding side over 40, we could write a proportion is equal to 12 over 30. All right, now you have to solve this little equation, and the easiest way to solve it is something called cross multiplying. So you're taking 30 times X and 40 times 12. Okay, 40 times 12 is 480, 30 times X is 30X. Then you divide and you get X is equal to 16. So anytime you're trying to solve for a missing side, all right, you need to set up a proportion. And in order to solve that proportion, you need to cross multiply. Okay, so put a variable on the side you don't know. All right, so here's another problem about a tree. Joan places a mirror 24 feet from the base of a tree. When she stands 3 feet from the mirror, she can see the top of the tree reflected in it. If her eyes are 5 feet above the ground, how tall is the tree? Okay, so it's good to draw what's going on here. There's the mirror. Ooh, look how pretty that is. All right, you see the reflection from her eyes to the top of the tree. Let's label all the stuff that they've told us. We're looking for how tall the tree is. All right, so once again, you want to make a proportion, like her height compared to the tree height, which we don't know. Okay, 5 over X. Now, if you wanted to, you could do tree height to her height, X over 5. But then you'd have to do this tree shadow here, okay, to this other distance from the mirror. So you'd flip that ratio over. Regardless, there's a bunch of ways you could set it up, but you're going to be cross-multiplying the same things, 3 times X and 5 times 24. Then you solve it, and you get X is equal to 40 feet, so the tree is 40 feet high. Okay, then we have the side-side similarity theorem. Okay, so you can actually prove that figures are proportional if all their sides are in proportion. Okay, so basically want to look at all the ratios of corresponding sides and see if they are the same. All right, we kind of already mentioned that earlier, but this is how you could actually use it in an additional example 7 here. So they give you the side lengths of the two triangles. All right, what we're going to do is actually now compare the ratios. So like A and D, okay, they're in the same order. Okay, so A matches up with D. So that ratio would be 3 to 9. Let me draw here. Okay, 3 to 9 is matching up A to D. Okay, the other ratio is 4 to 12. If we match up B to E, and the other ratio would be 6 to 18. Okay, so it looks like they might not be the same. But you got to reduce them. If you reduce them, look at this. You see they all become 1 to 3. So we know that by side-side-side similarity, these are proportional triangles. Okay? You can also do side-angle-side similarity theorem. Okay, now the sides are not congruent, but the angle in between the two sides is. Okay, so you have two pairs of sides that are in proportion. Okay, so the ratios being the same. Okay, like AB to BC and XY to YZ. Okay, they have the same ratio. And the angle in between them. Okay, that makes the two figures similar. Okay, so let's look at this problem here. Explain why these must be similar. All right, so let's pick the sides that would look like they go together. So like the shortest one, 12, we're going to go with the shorter one, 24, and then 18 to 36. Okay. Also, we know these angles are equal because we have vertical angles. So the vertical angles, now we have an angle in between the sides. Now let's see if those sides are proportional. Oh, look, they are. Okay, that's equal to a half, and that is equal to a half. So basically, the ratios of the two corresponding pairs of sides are equal, and that's a beautiful thing. By side-angle-side similarity theorem, whatever number that was, 7.2 or 7.3, we know that these two triangles are similar. Just make sure you match up the angles that go together, like Z matches up with X, okay, and V go together, and Y and W go together. You want to make sure to go with the sides in the right order. You can go smallest to largest, largest to smallest, but you have to be consistent in the same order. Okay, so here is a few for you guys to try. I want you to think about them, and then I'm going to tell you the answers in a minute. Okay, hope you figured them out there. For number one, you could actually prove that they are similar by side-angle-side theorem there. So you would take the ratios 6 over 9 and 8 over 12 to see if they are proportional, and you do. They're both 3/4. So you have two sides, and you got vertical angle in between them. And so you have by the side-angle-side theorem. For number two, the vertical angle, okay, is not in between the two pairs of sides that are given. So you cannot use it if you read that there. For number three, you actually have alternate interior angles being congruent. Let me highlight them here. So you got an angle there, which is congruent to the angle there. And this angle MTR is congruent to angle XWR. And so by angle, you know that these two triangles are similar. Okay? Here is the ratios you could write to solve this. Put the hypotenuses over x over 40, and then the base 10 over 25. Okay, then you would cross multiply. You have 25x equals 400. X is going to be equal to 16. For number 5, draw out the picture. You have a height of t for the tree, which we don't know. The shadow is 93. The guy's height 6. His shadow is 18. So your proportion that you could use is t. The tree's height to the guy's height, t to 6, is equal to 93 to 18. Okay, you just have to make sure that you are consistent in the same order. You know, tree to guy, height to height. Okay, shadow to shadow, tree to guy. Okay, be consistent with your ratios. Okay, guys, hopefully this video helped, and hope you enjoy the rest of your day. Take care. Wash your hands. Stay away from people. And hope you guys stay healthy. Praying for you all. And that's it. Bye-bye.